Hi everyone. In our last lesson we talked about how to do GCF or greatest common factor with numbers only. And today we're going to add variables in and then do the same thing. We're going to look for the greatest common factor or the GCF. So first of all, what we are talking about instead of just numbers, we are talking about terms. Or another name for that is monomials, one term, single terms. So your term might have a number part in front of it and then a variable part, and it could have more than one variable in it. So the idea is these terms also have a greatest common factor. Now we already know how to do the number part, so let's focus on the variable part. Let's say we had two terms, x to the third power, or x cubed, and x to the fifth power, and we wanted to see what the greatest common factor is. Well, a good way to think of it is expand it, using what we know about exponents. So instead of x to the third power, think of it as x times x times x, 3 x's. And instead of x to the fifth power, x times x times x times x times x, 5 x's. Now if you think about it that way, what you can see is that the common term is the 3 x's. So the first term, the x cubed, that's all it has, is 3 x's. Now the second term has those 3 x's plus 2 more multiplied onto the end. But the 3 x's are the common term. That's what is the same in both of them. So the greatest common factor is x cubed, is those 3 x's. So basically, what we're doing, instead of having numbers and trying to figure out what number we can divide by, we have variables. So really, what we're actually asking here is, if I have x to the third power and x to the fifth power, what's the biggest power of x I could divide by and still end up with just whole numbered x's, not have to break it up and use fractions or anything. And the answer would be x to the third power. And that kind of leads us into a shortcut. If you're trying to find the greatest common factor and variables are involved, you always take the lower exponent. If I have y to the fifth and y to the seventh, then y to the fifth is the greatest common factor. Or if I have z to the 20th and z to the 100th, then z to the 20th is the greatest common factor. Whatever the lowest exponent is, that's your greatest common factor. And it can work even if you have more than one. If I have x squared, x to the fifth, and x to the 10th, the greatest common factor would be x squared. It would be the smallest one of the three. All right. So now, let's say we are talking about monomials, or what we call terms, one single term. If I ask you guys to find the greatest common factor, or the GCF, all you have to do is do each part separately. Do the number part first, or the coefficients first, and that's what we just talked about in the last lesson. That's when you find the biggest number that can divide into each one. And you can use factor trees if you want. Then you go through each variable one at a time. There can be more than one variable in a problem. And you take the lowest power that is common among them. So let's look at an example. We have 3 terms here. And I said, what is the greatest common factor, or GCF, of these following 3 terms? So basically, step 1 is the number part. We have a 12, we have a 9, and we have an 18. Now this is what we just talked about in part 1. If you want to do factor trees and make a list, that's fine. I'm going to kind of jump straight to the answer since we've already talked about this. And I'm going to say the greatest common factor of those numbers is 3. If you made your factor trees for the 12, the 9, and the 18, the biggest number that I can divide all 3 of those by is 3. Now that's the first part of my answer, but it's not the whole answer because I have x's and y's to do too. So the second part, let's look at the x's. I have an x to the 4th, an x squared, and an x cubed. Using our shortcut, the greatest common factor is always the lowest power of x out of all of them. So the greatest common factor of x to the 4th, x squared, and x cubed is x squared. Now, the last one is the y's, and this one has a little trick to it. We have a y cubed, we have a y, and then we have nothing over here. There's no y's on the third one. Now, you might look at this and think, okay, I'm just going to take the lowest power of y, which would be y by itself, or y to the first power, and that actually would not be right, because we don't have a y. You can't have a common term if there isn't one of those terms in there. So as soon as you see over here that any of the terms does not have one of your things in it, your number or your variable or whatever, then that is not part of your answer. So we don't have a GCF for y, because the third term doesn't even have a y. So my final answer is just going to be these two things together, and basically just put them together. Our final answer is 3x squared. So the greatest common factor of 12x to the fourth, y to the third, 9x squared y, and 18x cubed is 3x squared. We can divide everything by 3 evenly. We can divide everything by x squared evenly. And we cannot divide by y because one of them doesn't even have a y. All right, so that's how this works.